Hi everyone, and welcome to the Sierra College Physics Lab, Experiment 7, Transient RC, RL, and RLC circuits. For part 1, we're going to be doing the RC circuit. We'll use a breadboard, a 4.7 microfarad capacitor, and a 100 ohm resistor. If you look at the colors, it is brown, black, brown, and gold. Brown is 1, black is 0, so you have 10. The multiplier of brown is 10, so 100 ohms, and gold with a plus or minus tolerance of 5%. Here is a 4.7 microfarad capacitor, and notice we have a long leg and a short leg. The short leg is the negative side. Be careful to put this in your circuit in the correct orientation. So I have the breadboard in front of me, and then I have the FG-100 DDS function generator. It is currently set to a square wave, and off that generator, 2 banana clips. Next, there is the Edipon oscilloscope with 2 banana clips attached, and a small amount of jumper wires. We're going to be wiring it as shown in the lab. And to do that, I'm going to add in a jumper wire, and that is going to act as my positive. Now, following in the same board, I'm going to jump over to the resistor. Let's go over into the other side. And now I'm going to put in the capacitor, but the long leg is going to go on the positive side. The short leg will go on the negative side. And out of the capacitor, I will attach that to the negative of the function generator. So what this is currently doing is it's making one loop where this is the grounded side. Now if I want to use the oscilloscope to measure across the capacitor, I'll use a jumper and attach it to my lead, and I'll put that on the positive side. And then I will ground the negative side. Now I'm going to adjust the frequency generator to 3 different measurements. We're going to be doing 50 Hertz, 100 Hertz, and 250 Hertz. To do that, when it's turned on, I'll use the cursor, and the cursor moves across the frequency. Plus to move up, minus to move down. The mode will let you change what type of wave it is. Square wave, frequency of 50 Hertz, and then run will get it going. You're going to be using this oscilloscope by adjusting the volts per division and the seconds per division. If the waves are too close together, we'll go to seconds per division, and we'll decrease the seconds per division, and that stretches the waves out. If they are too tall, we go to volts per division, and we can adjust that voltage to a more reasonable level. Now your measurement, we can press OK, and that does a hold on the screen. And from there, you can count your number of divisions, time, which is a time scale of units per division, and you're going to measure the half time it takes for the rise. Take a picture of the scope trace and the circuit. You will need to paste them into your lab. Paste a picture of the scope traces for each frequency below. Include a separate picture of your circuit. Don't forget to include 1-sentence figure captions. Use complete sentences. Measure and record the values of the resistance and the capacitor. Go ahead and use your multimeter to measure those, including plus or minus values. We're going to build the RL circuit. The R we are using is a 10 millihenry inductor, and the resistance we are using is a 47 ohm resistor. The colors that we have are yellow, purple, black, and gold. Yellow is 4, purple is 7, black is the multiplier of 1, therefore we have 47 ohms, and a tolerance of gold, which is plus or minus 5%. We're using the breadboard. I'm going to put the resistor in the breadboard. Directly across, I'm going to put the inductor. A small jumper wire in between. My black or grounded side. And these two leads will go to the function generator. And make sure that your grounded side or low side is on the end of the resistor. We're going to be measuring on the oscilloscope the voltage across the resistor, not the inductor, across the resistor. To do that, we'll take the clips and we can directly attach those to the resistor. Red to the high side and black to the low side. Be careful, as I said before, we do not want to be attaching the black, which is a grounded side, to the wrong side of the resistor. If you did that, you'd have current going through the inductor, coming out, and then traveling down the grounded side of the oscilloscope, thus making this a L circuit and not a LR circuit. So make sure to put the grounded side as a common ground and the high side, and you're going to use your oscilloscope to measure the voltage as a function of time for this circuit. For part 3 of the lab, you're going to be making an LRC circuit. You can have those in any order you want, but for this circuit, we're going to be measuring the resistor. So the resistor is going to be the last component in the circuit. So I'll take my inductor and attach it to the breadboard. Then I'm going to do my capacitor. And remember, the capacitor has a negative side. So I'm going to be working left to right of the circuit. So out of the inductor, into the capacitor, and the capacitor into the 1 ohm resistor. You will need to choose your components as you see, but I will choose the 1 ohm resistor. Black on the grounded side, and this will be my high side. These two wires will get attached to the function generator. You will use the oscilloscope and the banana clips to attach directly across the resistor. Make sure to have the common low side. So we have an LCR circuit in order. So the current flows down, goes through the inductor, through the capacitor, and through the resistor. This gets attached and makes one complete circuit. You'll be using the oscilloscope to measure the voltage versus time and get all information you need from there. So this is how to use the Edipon oscilloscope. You attach it to the power supply as directed, and we use a BNC connector. That BNC connector goes to 2 alligator clips, and those alligator clips may be directly connected to the element. If the element is too small, the legs being too small to reach, you can use small jumper wires and then plug those into the same rails as the element. Make note that this is a grounded oscilloscope, and therefore the ground has to be put on the ground connected side. For example, if these two are connected in series, with the resistor going to high, if you want to measure across the capacitor, you would have to put the high, the red, on the high side of the capacitor and the black on the low side of the capacitor. That's how we'd properly measure. If for some reason you decided to switch it and put the ground on the high side capacitor, what would happen is you would see that you would go through the resistor and then go directly to ground, thus bypassing the capacitor. And you would not have a, for example, RC circuit. You would have just a resistance circuit. All right, to use the oscilloscope, the on is near the bottom. It boots up, and you have an adjustment knob. You have volts per division, seconds per division, trigger, and OK. The OK works as a hold or a freeze. You can freeze the image on the screen, take your measurements, press it again to go back to live. Now, if you want to change your vertical or volts per division, you make sure you're in volts, and you're allowed to change the base by moving up and down. If you would like to change your horizontal, we go to seconds per division. That's your time base, and we can change that to microseconds, milliseconds, or even seconds. On the top is your coupling, your AC and DC coupling. Here is the function generator. The function generator, FG-100 DDS function generator. This power source is a 5 volt. It goes directly to the power. It can be used with the power supply given. Make sure it's connected to or set to 5 volts on the back. This also works on a BNC cable. That BNC cable can be used with banana plugs. So you can put it across an element or attach it to a jumper wire to use in a breadboard. So we power this on. Mode lets you change the type of wave, square, triangle, sawtooth, and such. The cursor moves along the frequency. You can change that by pressing up or down. If I would like to set this to 1000 Hertz, I'll set that to 1, cursor over, change that down to 1000, and now, right now, this is not putting out 1000. You have to press run. This stops blinking, and this is outputting a 1000 Hertz square wave. The amplitude is the knob on the side, and that will change the amplitude of the signal. If you would like to change the frequency, you cannot directly change it. You will have to press stop, adjust it, and press start again to your next frequency.